Wala silang komunikasyon, sira ang telepono.
The city itself has no power, no water service, and no telephone lines.
Every year, over 3 million earthquakes are recorded globally, and most of which go unnoticed. A powerful earthquake is the most terrifying and destructive natural occurrence that may occur anywhere. Even though they typically last only a few seconds, large earthquakes can have catastrophic consequences that may lead to the deaths of hundreds or thousands of people and devastating economic impacts. The strength of an earthquake can be defined by both its magnitude and intensity. The amount of energy produced by an earthquake at its focal point determines its magnitude, while an earthquake's intensity refers to how strong it is as perceived and felt in different areas. It provides a numerical rating based on its relative effects on people, the environment, and structures. Earthquakes are most commonly felt around tectonically active regions such as the Pacific Ring of Fire. Areas around this region, which include South and North America, Japan, and the Philippines, are generally characterized by high levels of seismicity and volcanism. The Philippines, in particular, is surrounded by zones of plate convergence where two tectonic plates collide. On its eastern side, the Philippine Sea Plate is being subducted beneath the Philippine Archipelago along the Philippine Trench and its northern extension, the East Luzon Trough. On its western side, meanwhile, the Sunda Block is being subducted along a series of trenches, including the Manila Trench in the north, the Negros Trench in the central Philippines, and the Sulu and Cotabato Trenches in the south. The Philippine Fault also formed as a response to the oblique collision between the Philippines and the Philippine Sea Plate. It traverses the Philippine Archipelago and extends for about 1,250 kilometers. Several other fault systems have also developed in different parts of the archipelago. In terms of seismicity, an average of 20 earthquakes are recorded daily in the Philippines, but most of these earthquakes are unfelt and can only be detected by a seismograph. Notable earthquakes in the Philippines include the 1976 magnitude 8.1 Mora Gulf earthquake, which was generated by the Cotabato Trench, the 2013 magnitude 7.2 Bohol earthquake, generated by the North Bohol Fault, and the 2017 magnitude 6.7 Surigao earthquake, generated by the Surigao segment of the Philippine Fault. In October 2019, a series of strong earthquakes generated by the Cotabato Fault system devastated the province of Cotabato and the nearby areas. The Cotabato Fault system is a network of strike-slip faults which predominantly produce lateral or horizontal movements. It cuts through the provinces of Cotabato, Davao del Sur, Maguindanao, Sarangani, South Cotabato, and Sultan Kudarat. It is comprised of several active faults that include the Imlang Fault, Makilala Fault, Balabag Fault, Makilala-Malungon Fault, North Columbio Fault, and South Columbio Fault. The series of earthquakes that struck Cotabato was initiated on October 16 with a magnitude 6.3 earthquake, followed by a magnitude 6.6 and magnitude 6.1 earthquakes on October 29, and a magnitude 6.5 earthquake on October 31. Due to the succession of these events, the affected areas suffered severe and extensive damages. According to the National Disaster Risk Reduction and Management Council, the series of earthquakes affected around 50,930 families in the provinces of Davao del Sur, Davao Oriental, and North Cotabato. It also brought about various geologic impacts such as tension cracks and earthquake-induced landslides, especially near the epicentral region in Makilala-Kidapawan City, Tulunan in Cotabato, and in Magsaysay and Bansalan in Davao del Sur. Liquefaction and subsidence in low-lying and water-saturated areas were also observed. Liquefaction was manifested by lateral spreading, which caused the ground to stretch open, resulting to surface cracks and fissures. Sand boil or sand blow caused by the pressure due to ground shaking, thereby squeezing the water out of the pore spaces between the soil and expelling wet sand from the ground, and road buckling and ground undulation, which resulted in wave-like bends or curves on the ground. Disaster strikes when we least expect it. Natural phenomena such as earthquakes and typhoons remain inevitable. Thus, prevention and risk reduction measures play crucial roles in mitigating our exposure and vulnerability to various hazards. However, building a resilient nation that can navigate through any type of disaster requires more than just plans. It also takes a collective effort and awareness to translate these plans into actions.